Welcome to another episode of Math Made Simple. I'm Mr. Jack, and I'm a secondary math specialist here at the Pique Lab. In this video, I will be analyzing a past year exam question. I've also prepared this question for you to download for free by clicking on the link in the description box below. So, let's get started. Let us take a look at the following question where we are given the extension E of a spring to be directly proportional to the force F newtons applied to it. In part A of this question, we are required to sketch a graph of E against F for the extension of the spring. Now, before we can start to sketch the graph, we must first take note of the relationship between E and F. We are told that they are in direct proportion. So do you remember the equation that models this relationship here? In the context of this question, E is equals to Kf, where K is the constant of proportionality. Now, we will also revisit a concept from the past. We have learned about the equation of straight lines. They have a very unique format. Y equals to mx plus c, where m is the gradient of the line and c is the y-intercept. So by comparing these two equations here, do you notice a similar pattern? Y models E, X models F, and M models K. What about the C at the back? Notice that for the equation E equals to Kf, there is no constant term at the back. To fix this, we will simply write plus 0 at the back, and we note that C models the number 0. So what does this tell us? For the graph of E equals to Kf, it models after a straight line that passes through the origin. Hence, for questions that require us to sketch a graph for two variables in direct proportion, we simply have to remember we need to draw a straight line that passes through the origin. With that, let's move on to part B of this question. For part B, when 6 newtons of force is applied, the same spring extends by 9 cm. Hence, by using this information, let us find the equation that connects E and F. From part A, we have seen that the equation is E equals to Kf. To solve part B, we simply have to find out what is the value of the constant K. To do this, we will make use of the information given. We substitute the value of F equals to 6 and E equals to 9. This will give us 9 equals to 6F, and by solving for F, we will get back 1.5. The final equation is E equals to 1.5F. Now let us move on into part C of this question. When 5 newtons of force is applied, the total length of the spring now becomes 12 cm. And with that, we are required to find the original length of the spring. Let us begin by drawing a simple sketch to illustrate what is happening to the spring. Our spring has been extended by a force of 5 newtons to give a total length of 12 cm. This means that the total length can be seen as the sum of the original length of the spring together with its current extension. To calculate the original length of the spring, we will first need to get out what is the extension caused by the 5 Newton force. So to do this, we will simply sub in a value of F equals to 5 into the equation we found from part B. This will return us E equals to 1.5 times 5, giving us an extension of 7.5 cm. And with the extension found, we can simply find the original length of the spring by taking 12 minus 7.5 to get out 4.5 cm as our original length of the spring. Thank you for watching, and I hope that you have enjoyed this video. Found this video useful? Give us a thumbs up and check out more by clicking on the links over here. You can also subscribe to our channel for more interesting videos. Until next time, stay curious inside and limitless outside. Bye!